Okay, good morning. Welcome to
FamilyMath454a.
FamilyMath454a. So today we're going to do the second part of our Coke curve, Coke snowflake, sorry, project. Yesterday we talked about what?
The perimeter and how it has the infinite perimeter.
Yeah, the perimeter goes larger and larger as we go through more iterations of the Coke snowflake. But not just gets larger and larger.
It gets infinitely large.
It goes to infinity. Because the area also gets larger and larger every step we go, right? So there's step 1 to step 2.
Yeah.
And then here's step 3. So the area is getting larger. How do we know the area is getting larger every time?
Because you're adding pieces on, but you're not subtracting anything away.
Yeah, we're always adding pieces on. So we know it's getting larger and larger.
Yeah.
But what looks different?
But it seems like you're adding smaller and smaller amounts.
Well, but that's what you did before. You added small amounts.
But
Yeah.
you end up adding more each time.
Yeah.
Yeah, so you're right. In the perimeter, we were making the pieces smaller and smaller, but we were just adding lots of them.
Yeah.
Here, we're getting smaller and smaller little triangles, but we are adding lots of them.
So
maybe it's the same thing. It's definitely getting larger, but the really real problem here that seems different is I can kind of draw a circle around this.
and it'll never go outside.
Doesn't seem like our shape ever gets bigger than that circle.
Actually, the circle could be a little smaller. It could be like,
Well, sure, it could be a little bit smaller, or maybe something kind of fuzzes out over here. Looks like I actually forgot this bit here. But or maybe I didn't. I don't know. But it doesn't seem to grow. The area doesn't seem to be infinite because it's inside of a circle,
Yeah.
and this circle has definitely finite area.
yeah.
Yeah.
So it seems. So this is a real puzzle. Like. It's pretty convincing that the perimeter gets larger and larger every time and goes bigger than any number we can find. Right?
Yeah.
So we're going to go through the same process today and see if we can figure out what the area is.
Okay.
All right? And we'll see. We'll see if we can make sense of this. Why does the area seem to be finite and the perimeter seems to be infinite? And after this, because you said this bothered you, right?
Yeah.
Yeah, well, I'm glad this bothers you. This is a weird thing. So how do you think we're going to approach this problem?
Well, we could do it in the same way that we did the perimeter. We could look at the area at different steps and see if we can find a pattern between them.
Okay. What do you think we should do?
We could do the same thing.
Okay.
It might be kind of difficult to find, because the area of triangles won't have base times height. So this would be the base and that would be the height.
Yeah, you're right. That might be hard, but what I'm going to do, I'm going to simplify that process for us. I'm just going to say the area of our original triangle is x.
That makes.
Okay. So we don't need to understand geometry completely here. So we don't need to have to figure out the base times the height, because maybe that's hard, or maybe it's easy. I don't know. But we're not even going to do that part, because we're just going to figure out. We're going to call the area x, and we're going to see what happens along the way.
Okay.
All right?
All right.
Yeah.
All right, here we go.